Clinical medicine requires a specific analytical lens. A patient presents as a vast, multi-layered biological system, and navigating that system effectively requires a method to translate complex data into a readable, logical framework. Internally, the body operates as a high-speed network of moving parts. We decode this network by separating it into two distinct sciences. The first is anatomy, the study of bodily structure and the static spatial architecture of the organism. The second is physiology, the study of the dynamic mechanics and functional processes that power that physical architecture. Before we can map an organism, we must establish a prerequisite, the specific biological criteria that distinguish living tissue from inert matter. Our roadmap begins by building the human body from its raw chemical elements, defining the specific processes that render it alive, and establishing the geometric grid used to navigate it. This dual perspective of structure and function allows medical professionals to organize biological data into a predictable, clinically navigable system. This architecture is organized into levels, beginning at the foundational chemical level. The human body contains 26 elements, but 4 account for the vast majority of its mass. These 4 pillars are oxygen, carbon, hydrogen, and nitrogen. At this level, individual atoms interact and bond to form complex molecules. As these molecules compound, they form level 2, the cellular level, the basic building blocks of life. The cell is the most basic structural and functional unit of any living organism. Biologically, the presence or absence of cells defines the boundary between animate and inanimate matter. Understanding this chemical and cellular foundation is critical because macroscopic disease or clinical failure often originates from a disruption at this microscopic level. As we scale up, individual cells collaborate to create larger functional architectures. Level 3 is the tissue level, where groups of similar cells align to perform a unified function. We see this physical process clearly as individual cellular strands continuously weave and bind together into dense, cohesive sheets of biological tissue. Level 4 is the organ level. An organ forms when different types of tissues combine to create a specific shape with a unique function. Level 5 is the system level, where multiple organs integrate to achieve a common, overarching goal. The cardiovascular, respiratory, and nervous systems are specialized networks that operate with deep interconnected reliance. Finally, level 6 is the organism, the stage where all distinct systems synchronize into a single unit. Structural anatomy tracks how biological complexity scales from a single molecule to a complete human being. With the anatomical structure established, we must shift to the physiological mechanics required to keep it animated. We identify a living body through the 6 basic life processes, the functional checklist that distinguishes a living organism from non-living matter. This diagram maps process 1, metabolism. This encompasses every chemical reaction occurring within the body. Metabolism consists of 2 phases, catabolic, which breaks down matter for energy, and anabolic, which uses energy to build new structural components. Process 2 is responsiveness. This is the ability to detect internal changes or external stimuli and react to maintain physiological stability. Metabolism provides the organism's power, while responsiveness provides the control system needed to navigate the environment. While metabolism and responsiveness provide immediate function, long-term survival requires 4 additional processes. Process 3 is movement, which includes intracellular material as well as whole-body biomechanical locomotion. Process 4 is growth, defined here as the physical expansion of the system. Growth occurs through increased cell size, an increased number of cells, or an increase in the material between those cells. As the organism develops, unspecialized cells take on complex, highly specific functional roles. This transformation is Process 5, differentiation. Process 6 is reproduction, generating new cells for repair or the creation of a new individual. These 6 physiological processes are mandatory. If any fail, the biological machine degrades, requiring clinical intervention. With the biological machine fully operational, clinicians require a standardized spatial language to navigate it. This is achieved through the anatomical planes, a three-dimensional coordinate grid used to communicate locations within the body. This diagram shows the first axis, the sagittal plane. It slices down the middle of the subject, separating the left and right sides. The second axis is the frontal or coronal plane. This slices vertically to divide the anterior front from the posterior back. The third axis is the transverse or cross-sectional plane. This slices horizontally to isolate the superior top from the inferior bottom. Adopting these exact terms eliminates spatial ambiguity during medical diagnosis or surgical intervention. These planes provide the geometric grid used to interpret MRIs, CT scans, and surgical charts in modern practice. Our model is now complete, scaled up from 4 chemical elements, identified life through 6 functional processes, and applied a 3-plane coordinate grid. This structured perspective allows us to view human anatomy through a rigorous, analytical lens, forming the foundational mental map shared by the medical community. Mastering these first principles establishes the essential baseline for clinical navigation. It creates a framework where a practitioner can begin to accurately identify, track, and address pathology within a complex organism.